guys. Well, in this video, yes, you are correct. Those are ClearPath servos, and this will be ClearPath Servo Upgrade for my original Precision Matthews 727M, along with a Toradol power supply. This is a Kelly 7270 from Automation Technologies. It's a 72 volt power supply to go along with the ClearPath servos. These are the 55-foot cables, and this is the power cable and the control cable. I'm going to make 3 cables out of each one. The ClearPath supplied cables, they have the connector on both ends. These are sealed connectors, so I'm just going to split it into thirds, and then the Z-axis I will use they're Molex Mini Junior Fit connectors, and I will just make my own connectors. I'll do the same thing for the control cable, and then that way I can have 3 15-foot cables. It's a lot cheaper to go this route than it is to buy 3 individual 10-foot cables, which aren't going to be long enough. Now, although I originally chose the DMM servos, I really did look really hard into the ClearPath servos. I just chose to go with the DMM at that particular time. Both are great servo motors. The really plus thing about the ClearPaths are the ease of installation. You don't have to have the drivers because it's all integrated, so it makes installation fairly simple, and you don't need a lot of space in a control cabinet, which is the reason that this is a good upgrade for my current control system. We're going to have to rewire the control cabinet, remove the original 48 volt power supply with the 3-phase steppers, and put in this 72 volt. We're going to have to try to make room because this is a little bit bigger, but I think it's going to fit in there just right. And then we'll do the cabling, the installation, and we'll do the auto tuning. My buddy Wyatt's been running the ClearPath servos on his Precision Matthews. He was actually the first person to follow along as I converted my machine, and he converted his. He originally went with the 3-phase steppers, but then converted over to ClearPath. We've become really good friends. I talk about Wyatt quite a bit, so you guys are probably familiar with hearing his name. He's running the ClearPaths. He's happy with those. So I had the opportunity to pick up these at a little bit of a discount because the gentleman who had purchased all the components to do the conversion fell in bad health and emailed me and asked if I knew anybody that wanted these or if I was interested in these servos. He still has his meal for sale, so if you guys are interested in that, anybody, just let me know, and I'll put you in touch with him. Alright, well, for the ClearPath upgrade, we're going to have to make some changes to our control box. Now, it's been a while since we've been in here, but this is our 48 volt power supply that supplied power to our 3-phase stepper motor. And so this will need to be removed, and then we'll need to make room for that here. I think I'm going to be able to just take this tri-power power supply, stand it up, and I'll be able to fit that power supply right there straight in here. These drives will no longer be needed, so we can remove those. So we'll free up a little space there, so if I need to, I can take and move my tri-power power supply and relocate it up here and have plenty of room. Alright, so I'm going to get this stuff removed, and then we'll see where we're at. Alright, to continue with the ClearPath servo upgrade, I removed the old power supply and installed this 72 volt Toradol power supply. Now, this power supply is quite a bit bigger than the 48 volt power supply I had in there. However, all I had to do was just turn the tri-power power supply and stand it on in, and I was able to fit everything in real nice. So, worked out really well. So we've got it connected. All we did was just clip the connections for our original power supply. It's 110 volts coming in and a neutral. They tie together with the power supply. Follow the directions for wiring that from Kelly. And we have our 72 volts. This one goes out to our Z-axis fuse here. And then I've got these two on this board. I don't know if you can see them. And that'll be my X and my Y. If I later on add an A, I'll put it on this board just to kind of equal out the load. You can run a jumper from side to side so that you get full power supply amperage, but I don't think it's really needed at this time. Here is the old neutral, or the negative, for the power supply. Now the ClearPath power goes directly to the servo motors, so I think what I'll do is I'll add a slice here to tie in all of the neutrals, and I'll pull the power right off the fuse. Alright, I'm going to go ahead and remove my old stepper drivers, clear all that area out, clean that up a little bit, remove my aviation plugs, and then we'll get ready to wire up the ClearPath. Alright, so next all I have to do is wire in my pigtails. Now these are for the power, and all I did was just make my own ends. These are mini Molex Junior connectors. Alright, so in order to make these cables up, you need to have the insulation right where that notch is, and it doesn't need to extend. The wire cannot extend past this notch. If it does, then you'll end up, the connector won't want to push in there. So without the crimping tool, the best way to do it is to fold one of these over, like so. And then fold the other side over, like so. And just kind of pinch it. You don't want to have it so tight that it deforms the bottom here, because if it does, then it won't slide in. You could fold these over, but I'd rather not, because I'm going to solder that. So we'll do that next. You see how it's clear, the wire's clear that notch? Alright, I'm going to try to get this on camera here, show you how to solder, how I solder this, if I can see myself. Alright, still a little blurry for me, but just want to heat this up. That should work. You don't want to get too much, and you don't want to fill up that groove right there. See that notch? The notch right there, you don't want to get any solder in there. You just want to get it nice and make a good connection right there at the solder joint. I mean at the where the wire is. So now you just have to do 8 per plug on the signal wire. There's 8 of these wires, so we'll do all these next. Then you have 2 ends for the Z to do, and then the X and the Y cable on one end. So let me get those done. And these are actually panel mounts, so these clips here will allow it to snap into a panel. Since I had the aviation plugs before, what I'm going to do temporarily until I can machine a new plate is I'm just going to poke these through the hole, And then we'll make our connection on the outside. And then I'll just wire these up. So we have power, and then we have our ground. So the 72 volts from the power supply come out here. As we showed earlier, these are X and Y, and this is our Z. And they came up to this terminal board that I added. I just borrowed some from down here that I had extra. Moved them up here. And so we'll run our ground here, and then we'll run our power comes through these fuse holders here. These are the same fuse holders I used for the stepper motors. These are 5 amp fuses. I think the 5 amps will be good for these ClearPaths. I didn't really see any documentation on what size fuse to use. So I'll just disconnect this power wire here, connect our pigtail up to here and over to here. Alright, so we're just going to take this pigtail here and we're going to wire it into our ground block and our fuse holders. The red wire is our positive and our black wire is our ground. Now they're very specific in the instructions not to wire these up backwards, so if you do, it'll damage your servo motor. So we definitely want to keep mindful of that. Our ground block here, I've ran each one back to the power supply, but I'm also going to put in this jumper and tie all 3 of these together like so. Alright, so I'm going to disconnect these and we'll start wiring up our pigtails. Alright, so I've got the 3 pigtails wired up. All we have to do now is wire up disconnect our old step-in direction and install our pigtails for the ClearPath step-in direction. And I've put wire ferrules on the end to make it a little bit easier. Some of these we're not going to use. So we'll start out with the Z-axis. So let's take a look at the schematic real quick. So we're going to be using the white black wire is tied together, and that is going to be our 5 volts. So what I've done on our cable here is I just went ahead and tied them together with a wire ferrule. And then our yellow and brown will be our step-in direction. It's our orange, and our blue is our enable circuit, orange and blue. So what I'm going to do now is I'm just going to disconnect these 3 cables so that we can wire in our pigtails. Alright guys, so I've got all of my pigtails wired up, and now all that's left to do is I've soldered my enable circuit. I tied these 3 together, and so that way I can just have one wire going to the breakout port. I'm going to put some heat shrink around that, and then we'll button all this up and we'll be done. Well, I've got the ClearPath servos installed on the Y, X, and Z axis, and I'm going to go ahead and start doing the auto tune process. I have the Z axis hooked up currently. As you go through the software, it's pretty self-explanatory. There's also a couple of good videos from ClearPath on this. Basically, you go in and you set up the parameters. It'll prompt you with a bunch of screens, and then you're going to jog manually the extent of your travel. And then once you do that, you can go ahead and start the auto-tune process. So let's begin that now. You're going to hear a lot of high-pitched, low-pitched grunts, high-pitched squeals, fast, abrupt moves, jerking, all of that sort of thing. You can always exit the auto-tune process by hitting the escape key. So here we go. It's going to prompt you to click run. Starts out really slow, but it has a bar down here just barely starting to move, and as it progresses it'll get increasingly faster. This is probably going to be about a 15-minute process, so I'll pause the video and then we'll come back later on when it gets a little bit more into the tuning process. Alright, we're starting the auto-tune process on the X-axis. Z was pretty uneventful, it's just a little bouncing and jerking, but it did move throughout the full extent. Came up, everything was okay. So now we're just doing the X-axis. We're just started here, and we'll come back and check it once it gets a little further in the process. Alright, it's about 15% in. You can hear it jerking and bouncing. You can see it's doing some torque saturation checks here. Earlier it was flashing red, now it's amber, so I'm guessing that's okay, or at the edge of the limit there. Alright, you can see it moves a little bit, maybe a rotation, and then does this little jerk, and it kind of does that all the way down the length that you predefined in the setup, and then it does it all the way back. That was it. It's 100%. So now you do is you just click next. And then it'll allow us to move it. We can set our RPM. This motor is rated for around 940 RPM. So we'll set it for, say, 900. And then we can move it. Pretty good. So once that's done, you're happy with that. You can see that our setting here for our RMS is the max is 17. We're at about 8%. Everything looks good. We can disable our ClearPath here. Our motor's disabled now. We can click next, and then I want to change my motor identity settings. It comes from the factory with the default no load settings, so you can just hook power up to it, come in here and actually have movement. And now that we've auto tuned it, I want to save this as a different name. So you can see it comes up as unloaded, but I'm going to change this to X-axis. Like so. And then down here I'm going to put just a couple of notes. This is a RM 2005 and it's 5mm pitch, and it's for the Precision Matthews 727M. Alright, we'll hit OK. It'll save this, and you can see it's changed the name up here now to the X-axis. It's been modified. Our input resolution is 800. That is what I ran my steppers on, so I didn't have to change any of that. You want to make sure homing is disabled, and everything else looks good. Going to leave the RAS profile at 16 milliseconds. You also want to make sure the step and direction is checked when you exit this program. And then we can power off. Now it'll take a second or two for the power supply to bleed off. Your LED will change. See this one, it's off now. Alright, now I'm going to get set up and we're going to do the Y-axis. Alright guys, well, servos are in, the ClearPath servos are installed. Nice and quiet. Rapids I've got set around 200, which is plenty fast for what I'm used to. Over the years I've had to decrease the rapids on those three-phase steppers I originally had. Started out around 100, but I had to drop down. To about 70 in order to not lose steps. You can see these rapids are a lot nicer. And just running some sample code that I run parts on. The spindle I have turned off, but you can hear how quiet it is when it's running. This is running at a feed rate of 25 inches per minute. Nice and quiet. So I'm pretty happy overall with the ClearPath. I'm going to redo the plexiglass cover that I had over here for the X-axis, and I'll probably make something that kind of just goes around this whole thing. I'll remove that and just have this whole thing covered. My Y, I did make an aluminum sheet metal cover that bolted right here, and that kind of covered everything, so it turns out that one I had to replace earlier. The plexiglass, it tends to get brittle and crack over time, so just not going to work. I have replaced my covers here, back on here. This is just some sheet metal. I just kind of formed a piece of sheet metal over my Y-axis mount here, and then just put a couple screws in here to hold it, and of course some silicone just around there. That works out really well. For the X-axis cover, I just replaced that with the ClearPath. Again, I just formed it around my spacer here, removed the little cover I had there, and just formed this. I've got a little screw here. It also kind of covers my limit switch there for my home switch. So I've got a screw on, a couple of screws holding that side down. I added this little gutter system, so any coolant that runs down, it'll just progress back towards the drain there. Ran a little code yesterday and made some new soft jaws. I made about 3 sets of soft jaws. It was just a couple little operations, but it seemed to work really well. There's a couple of things I've had to change in my procedures with the ClearPath. Number one, the ClearPaths have no resistance, so I have to lock my Z-axis down when I'm not powered up. Otherwise the head will slowly fall. I didn't have that problem with my stepper motors. However, with these ClearPaths, it does. I also went ahead and wrote some G-code for a little warm-up cycle. Starting out with slow speeds, about 75 inches a minute, which is where my rapids were earlier with my stepper motors. It's quite a bit different, but it just kind of goes through the travel of the X, the Y axis, and move the Z up and down a little bit just to kind of get things warmed up if there's any kind of just kind of build some heat up into the axis here before we start machining. I think it's probably a good practice to do that. Then we progress up to 100 inches per minute, 150, and our full rapid speed, which is 200 inches per minute. these ClearPaths on here. And we're moving 13 inches in the X there, 10 inches in the Y. About 8 inches in the Z there. I don't want to bring it all the way down. I've got my tool in there. I don't want it slamming into the vise. So you can see it's quite nice. So I run this cycle a couple of times, and then I'm usually ready to start machining. We'll see how it works out. I've only done it for about 3 days now, so seems to be working out okay. So far I'm fairly happy with that. Now that I'm at 200 inches per minute on my rapids, I'd like to see a little more, but one thing I do want to point out is the Z-axis motor that I went with, 3432S, and I can only get 190 inches per minute on the rapids for that particular motor. The smaller motors that I went with for the X and the Y are 3421S. Now my buddy Wyatt's actually running that same motor on his Z-axis, and his head is about 15 or 20 pounds heavier than mine because he's running the marathon motor, and he doesn't have any problems, and he can get 200 inch per minute rapids out of all 3 axes. So originally I thought that I would want the heavier, bigger servo for the Z-axis just to be sure. With all the problems I was having with my 3-phase stepper motors, I didn't want to take any chances, so I went ahead and went with a little bit bigger servo on that. However, it will slow down your rapids because the max RPM for that particular motor is like 1090 versus 1400 or 1390, or maybe it's 1410. I think it's 1410 for the X and the Y servos. So you just can't, with the RM 2005 ball screws, you just can't get 200 inches per minute out of that bigger motor. Something to think about if that's more important. I just wanted to make sure that I had enough power to get it up and down, and that's the servo that I recommended for the Z. So that is the servo that this gentleman bought when he was starting to gather up parts for his conversion, and so that's what he had, and since I got them from him, that's what I ended up with. If you're interested in the ClearPath servos and you're doing the Precision Matthews CNC conversion following my plans, you can see that it fits quite nicely in the configuration that I already had set up. Stop by and visit the website if you're interested in any of my conversion plans. We'll also be adding the ClearPath wiring diagram into my plans. If you purchased my plans in the past, send me an email if you would like the wiring diagrams for the ClearPath servo, and I'll forward those on to you. Thanks for watching, guys. Please subscribe to the YouTube channel. Thumbs up if you liked the video, and most importantly, be safe.